Hello, Algebra 2 students. This is Mrs. Allison, and today we're going to look at writing the equation of an absolute value function given the graph. So if we remember, our transformed function looks like this, okay, where we have our transformations of a, b, and h, k. Now, we're always, when we write the equation, going to let b equal 1. So we're not going to look at a horizontal stretch or compression or reflection over the y-axis. Instead, we're going to view it vertically. So the first step is always to identify our h and k, which is going to be our vertex. So here, in this function, our h and k is at this point here, -1, 2. There's my h and there's my k. Okay, so I can go ahead and plug that into my equation. Keep in mind, if it's x minus -1, that's going to become +1 here. And then my k is +2. Okay, so we can just double check here, just to remind ourselves, if I want to shift left 1, it should be x +1, and I'm going up 2. Okay, now I need another point, so I'm going to pick any point that I want that's a nice point on the graph. So for example, I could use this point here at 1, 4. And I'm going to plug that point in for x and y in my equation. So I'm going to plug 4 in for y, 1 in for x. And now I'm left with one variable, which is a, that I can solve for. So to solve, my first step is going to be to subtract that 2 over. I'm going to move that 2 over to the other side because my goal is to get a by itself. And when I do that, I end up with 4 minus 2 is 2. I still have the a there. And then I'm going to go ahead and simplify inside the absolute value bars. This 1 plus 1 gives me 2. And remember, the absolute value of 2 is just 2. So I have 2 equals, and this is being multiplied here, 2a. So if I divide both sides by 2 to get a by itself, I know a is 1. Which means in this function I can see I'm not actually vertically stretching or compressing my graph at all because a is 1. So my final equation, when I write my answer, is going to be y equals, or g of x equals, a is 1, so I can either put that 1 in there or leave it out, x plus 1, that represents a shift left 1, plus 2. Okay, so let's take a look at another example here. Once again, we're going to let b equal 1, so we're solving for a, h, and k. So my vertex is going to be at this point here. Okay, just like we found the vertex here, I'm going to find the vertex, and it is at 2, 3. So that's going to be my h and my k value, which means I went, fix that there, k. I went 2 to the right, so that would be x minus 2. And I went 3 up to get to my vertex. Because remember, our parent function, the vertex starts at 0, 0. So I know I went 2 to the right and 3 up. Okay, then I'm going to pick a different point on the graph. So I'm going to use this point here at 3, 1. Okay, we want to make sure it's a nice point. We don't want decimals or fractions when I pick my point. I'm going to plug that point in for x and y. So I plug 1 in for y, okay, 3 in for x, and now notice I have one variable a I can solve for. So my first step, I'm going to subtract that 3 over to the other side. 1 minus 3 gives me -2. Okay, and then inside the absolute value bars here, 3 minus 2 is 1. And the absolute value of 1 is just 1. So my answer, a, is equal to -2. So I can go ahead and write my equation. Y equals, or g of x equals, okay, my a is -2, x minus 2, because we went right 2, and plus 3. Okay, so the important things to remember here is you have to find your vertex. That'll go in for h and k. But remember, you can always use your transformations because your parent function does start at 0, 0. So I know my vertex tells me where I shifted left and right and up and down. And then I pick another point to plug in, and then I can solve for a. Okay, so now that we went through the lesson, you can go ahead and complete the assignment that goes with it that has you practice writing the equation of absolute values. Have a great day.